To start this tutorial, the first thing we will do is go to the Curve tab and use the ellipse command. From the front view, we will type 0 to set the center of the ellipse. Then we will type 65 divided by 2, because we want the total width to be 65 millimeters, and starting from the center, we need half of 65. Press Shift or activate the ortho option and click on the left side. For the height, we will type 27.5 millimeters. Now let us go to the upper left corner of each viewport. We will open the menu and select Pan, Zoom, and Rotate, and then choose the option Zoom Extents All to center the content in each viewport. To continue, we will maximize the front view. Inside the submenu of the Line command, we will use the From Midpoint option. Type 0 and press Enter to set the center of the line. Then type 37 divided by 2 to define the length of the line. Press Shift or activate the ortho option and click on the left side to create a straight line on the x-axis. Next, select the curve, and using the gumball, drag the small sphere to extrude the curve along the z-axis until it goes beyond the ellipse. Now select both the ellipse and the extrusion. In the upper left corner, use the Trim command to cut the lower part of the ellipse. Press Enter to finish, and now you can delete the extrusion and the central line. Bring back the 4 viewports. We can now change the display mode to shaded to better appreciate the model. The next step is to analyze the curve to check its length. Go to the Analyze tab and use the Length command. As you can see in the command bar, the exact length appears. It measures 150.105 millimeters. Now we will return to the Curve tab and use the Line from Midpoint command. From the front view, type 0 to set the center of the line. Then type the exact measurement of the ellipse, 150.105 millimeters, and divide it by 2. This way, we will create a line with the same length as the ellipse. Now we will divide this line into 9 segments. To do this, select the line and, in the Point command submenu, use Divide by Segments. Type 9 in the command bar and press Enter to confirm. Next, we will change the curve to another layer and hide it. Use the Line command and, with OSNAP active, create a line between the 2 points located in the center. Then select this line, go to the Solid tab, and use the Pipe command. In the command bar, change the output to sub-D, then type 1.5 millimeters. Press Enter, and then press Enter 2 more times to create the pipe. Now we already have the first part of our model. Select the pipe, press the middle mouse button, and then choose Hide. You can invert the visibility using Hide Swap so that only the pipe remains visible. In the Sub-D tab, enable the Edge Selection filter. Double-click on the edge at the far right to select the entire loop. Now use the Insert Edge command to add another loop. Move the mouse as close as possible to the right edge and click to create the new loop. To soften the right end, select the loop again and use the Remove Crease command. Select the loop we created and move it slightly to the right with the gumball. Remember that this is an organic model, so the measurements may vary and each model will be unique. Without deselecting the loop, click on Insert Edge again to create one more loop. If you prefer, pause the video at this moment and carefully adjust the edges from the front view so that the result looks closer to the tutorial. Select the loop near the right end, and while holding Shift, use the gumball to scale it uniformly. Adjust the position of the edges to achieve a similar shape to what you see in the video. To project these changes to the other end, use the Reflect command. Select the solid. In the command bar, select the Y-axis. From now on, all edits will be reflected on the other side. Take your time to achieve a result similar to the video. It is also important that there is a bit of space between the solid and the end of the curve we created, because later we will connect them using a bridge. Once you finish editing the solid, you can remove the reflection. Select the solid, click on the Reflect command, and in the command bar press Remove Existing Reflect Symmetry. Maximize the front view to make the work easier. Select the solid, then type Mirror in the command bar. Make sure OSNAP is active. Select the point on the right end, and while pressing Shift, click on the top to create another solid. You can also use the Transform tab and click the Mirror command directly. Repeat this until you fill the 9 segments we created earlier. Once you have all the solids on the right side, you can select them all and mirror them to the other side. Remember to check that there are exactly 9 segments. In the video you will see 10, but this is corrected later. To avoid mistakes, make sure you have 9 segments, not 10. From the perspective view, go to the Sub-D tab. Use the Bridge command to connect each of the segments. First, select the faces of one segment. If you make a mistake, hold Ctrl and click again to deselect. Select the 8 faces of one segment, then press Enter. Only the selected edges will remain. Now select the faces of the adjacent segment. Once you have them, press Enter. In the pop-up window, change the segments to 2 and press OK. Now we have the first bridge created correctly. We need to repeat this same process for all the segments. Take your time. I will speed up the video so it does not get too long, but the procedure is the same for each segment. Pause the video if necessary until you complete the process. Once we have all the bridges created, we only need to shape the bangle. In the Transform tab, we will find the command Smart Flow by Curve. First, we will show the line we created at the beginning and move it down with the gumball until it is close to the bottom of the solid. We will add this curve to the selector as the base curve, since it has the length of all the segments combined. Then, as the target curve, we will use the ellipse. Finally, we will add the solid as the deformable object. And there we go. We will use the flip option on the base curve to rotate it. This way, the model adapts to the outer part of the ellipse. Simply accept the command, and now we have our final model. The only thing left is to add the details. Clear the viewport so only the model remains visible. We now have our model practically finished, so let's switch to the front view, which will help us in the next step. Afterwards, we'll focus on the upper left part of the model. In the Transform tab, use the Copy command. In the command bar, select In Place to create a copy in the same position. Move one of the elements to another layer and hide it to keep it stored. Now go to the Curve tab and create a line that crosses the bridges located on the upper left part of the model, as shown in the video. You can use OSNAP to create the line from the points, but it does not have to be exact. You can change the gumball by right-clicking at the bottom to easily adjust the position of the line. Create another line for the other bridge. Now select the solid and use the Split command. Then, as cutting objects, select the 2 lines and press Enter to execute. Delete the 2 ends and keep only the cut segment. We will use this surface to add the gems to the model. Now display all the views again and adjust them to the content as we did earlier. Select it, then go to the Diamonds tab and use the Automatic Pave command. Add the surface to the selector. For this model, we will use gem sizes of 1 mm, 0.8 mm, and 0.6 mm. Then remove the size of 1.3 mm, because for this model it is too large. Click Select Point, then click on the upper part. If you prefer, activate the gem visualization mode. Change the direction to one of the ends and press Enter to execute the command. The gem computation will start and will continue until there is no space left. Then simply delete the gems you do not like. In my case, I will remove the smallest gems from the ends and leave it like this. But feel free to change positions, or even add more gems. I think this is perfect, so I will move on to the prongs. The parameters will be diameter 0.6 millimeters, over girdle set to 0.2 millimeters, and under girdle set to 0.4 millimeters. Finally, extension for manufacturing will be 0.3 millimeters. Click Automatic Generation. The more gems there are, the more time the computation will take to achieve better accuracy. The automatic pave command allows us to choose how to finish the ends of the piece, so the final result is always personal. Once the computation is complete, click Add Prongs, and then finish the ends by adding prongs wherever necessary. Take your time to leave the model exactly how you want it. Remember that you can always remove prongs and add others to customize your design. When you are done, go to the Cutters tab. For this model, we will use Preset 4 and activate the cutters. Now we can accept the command to create our pave. Then simply show the complete model and hide the surface we used to create the pave. Move the surface to the model layer and the model itself to the first metal layer, together with the prongs. To finish, go to the Solid tab, select the model, and use the Boolean difference command. Press Enter to accept, then select the cutters, and press Enter again. If you hide the object and gem layers, you will see that the metal is already prepared for the gems. Our bangle is now finished. I will leave a reference render, but remember to let your creativity flow and create a beautiful image of your model. Share it with us.